everyone. We want to talk about parametric equations. Now a parameter is an external variable to the problem that helps us describe something about the problem. So for example, if I said let x be a function of t and y be a function of t, then t would become my independent variable that I could describe the equation by. So for example, let's consider x equals t plus 2 and y equals t squared minus 3, where t could be any real number. Now I have no idea what this looks like, so let's do it the old-fashioned way. Let's just plot points and see what we get. So in this situation, plotting points means I'm going to plot t, x, and y. So let's choose values for t. Let's say -3, -2, -1, 1, 2, 3. Then the corresponding values for x would be -1, 0, 1, 2, 3, 4, 5. And then the corresponding values for y would be 6, and if t was and 1, and -2, and -3, and -2, and 1, and 6. So if I said let's plot the xy points to see what we get something that looks like this. This looks strangely familiar. If you say, hey, I recognize that, just looks like a parabola. Then the next question would be, could I rearrange this to put it just in terms of x and y? Well, I usually can. That's not an automatic. So if we went to this equation here and said, let's solve for t in terms of x, we'd find that t equals x minus 2. And now take that t and insert it here, we'd see y equals x minus 2 squared minus 3, which we recognize is a parabola with vertex at 2, -3. Now let's consider another problem where I've defined x and y in terms of cosine and sine, but I've also put a restriction on t. T is only going to range from 0 to pi. So to put this together, what we probably want to do is use the relationship between sine and cosine, mainly the cos squared plus sine squared is 1. So if I solve for cosine in this statement here, I'll see cos t is x minus 1 over 3, and sine t is y plus 4 over 2. Now if I take the sum of the squares, I'll have x minus 1 squared over 3 squared plus y plus 4 squared over 2 squared, which is essentially cos squared plus sine squared, so I know that would equal 1. And we recognize that is the equation of an ellipse. With center at 1, -4. However, that restriction right there means it's not going to be the whole ellipse. Because t, which goes this way, is only going from 0 to pi, this will only represent the top half of the ellipse. Okay? Now let's consider this one here. I'm not going to mention any restrictions, so let's see what we get. Rather than make a table of values, let's just be clever and solve for t and then plug back in. So in this case here, the square root of t would equal x plus 3, so t would be the square of that. And if I put it into this statement, I get the parabola x plus 3 quantity squared plus 1, which seems rather simple. That would be a parabola basically that looks something like this. However, that statement right there means that t cannot be any real number. In fact, that statement right there means t can only be greater than or equal to 0, which is a restriction that I did not mention. But if t can only be greater than or equal to 0, then going over to this statement here, okay, that would mean that x, okay, is restricted and only going to be for the non-negative t's. So we're only going to get things to the right of the vertex. So what this is, this would be half the parabola. Particularly the right half of the parabola with vertex -3, 1. And finally, let's look at a fairly complicated example of one. Now, I don't have cosquared plus sine squared available in this problem unless I rework this. So if I raise both of these quantities to the 2/3 power, I would get x to the 2/3 equals the cos squared, and I would get y to the 2/3 equals sine squared t. One of the benefits of using parametric equations is you can use whatever manipulation you choose to make the thing work as long as it's legal. So because the sum of the squares is 1, I will get x to the 2/3 plus y to the 2/3 is 1. Now this is a very strange function which we're going to analyze further in the later sections, but because of the nature, x can be positive and negative, and so can y because I'm squaring them. But also you notice if x is 0, y will end up being plus or minus 1. If y is 0, x ends up being plus or minus 1. So we do know there are 4 points on this shape, namely 0, negative 1, 0, 1, 1, 0, negative 1, 0. But the question is, how are they related? Well, it turns out it's a very strange but very cool shape that looks like this, where I have spikes and points. I have cusps at each edge. I affectionately call this one my ninja throwing star.